This cross-section of the human torso shows how, in terms of physics, the abdomen functions as a sealed, pressurized containment vessel. The abdominal wall, composed of interlacing muscles and a tough connective tissue called fascia, acts as the primary barrier responsible for maintaining this internal pressure. Ordinary actions like coughing, sneezing, or lifting a heavy object rapidly compress this container, creating a sudden, massive spike in internal abdominal pressure. If that pressure wave strikes a pre-existing structural weakness or a microscopic tear in the muscle fibers, the system buckles. In this simulation, internal fatty tissue or a section of the bowel is forced through the compromised section of the wall. This is a hernia, a literal structural failure of the body's internal containment system. The abdominal wall is not a uniform shield. It contains natural evolutionary weak points where pressure breaches are statistically most likely to occur. This snag of the lower abdomen highlights the inguinal canal. Because it creates a natural gap, the groin is the most common site for containment failures. Other failure zones include the umbilicus, or belly button, and previous surgical scars, where tissue has lost its original integrity. When you stand upright or strain, gravity and internal pressure push organs outward through the breach, creating a visible lump or bulge. Lying down often causes the bulge to disappear, as gravity pulls the displaced tissue back through the opening and into the main cavity. A hernia remains stable as long as the displaced tissue can freely move back and forth through the structural opening without resistance. In a scenario called incarceration, the protruding tissue becomes trapped outside the abdominal wall and cannot return to the cavity. This creates a mechanical danger. The rigid muscular hole acts as a tourniquet, pinching off the blood supply to the trapped tissue. This condition is known as strangulation. Without restored blood flow, the trapped tissue will face rapid, irreversible death. Critical warning signs include intensifying pain, nausea, and vomiting. Visually, the hernia bulge may turn red, purple, or dark. At this exact threshold, the hernia becomes a time-critical medical emergency, requiring immediate surgery. While the body heals most wounds, it cannot close a hernia tear. The constant internal abdominal pressure forces the gap to remain open. Lifestyle changes like weight loss or using external supportive belts may manage the symptoms, but they do not repair the underlying breach. Because a hernia is fundamentally a mechanical hole, it requires a physical, mechanical intervention to permanently resolve. Modern repair surgery focuses on a single goal: manually pushing the protruding tissue back into its proper containment cavity. To reinforce the site, surgeons apply a synthetic mesh patch. This woven material distributes tension across surrounding healthy tissue. The mesh acts as a permanent structural reinforcement, allowing future pressure spikes to deflect safely without pushing tissue through the gap again. Viewing the abdomen as a mechanical system empowers patients to recognize these structural failures early and seek the necessary physical repairs before they escalate.